This is PreCalculus 12, Chapter 4.4. We're going to be determining restrictions on composition functions. And this is very different than restrictions on combining functions and are more difficult. And recall that we take the most restrictive domain for combining functions. And the only way to do this is through an example. So f of x equals square root x, g of x equals x squared plus 2. Determine the domain of f of g of x and g of f of x. The domain of f is x is greater than or equal to 0. The domain of g is x is all reals. The range of f, y is greater than or equal to 0. And for g, we have y is greater than or equal to 2. And that's because this is a quadratic. It's a quadratic. This is concave up, so we must have a minimum point. And this is in vertex form. It's 0, 2. And y is going to be greater than the q component of the vertex. So let's look at the first one, f of g of x. We just substitute g of x inside the square root. We get the square root of x squared plus 2. The domain of f of g of x, we ignore the domain of f. The only domain that matters is our innermost g of x. And the domain of g of x is all reals. Okay, and we verify that that works. So no matter what we plug in here, it's always going to be positive because the range of g is always positive. It's greater than 2. Now, to calculate the range of g, we know the minimum value is 2. We can substitute 2 into here because that's the range of g. This is g. And we get y is greater than or equal to square root 2. The other way is to plug in the x value. The minimum x value is going to be 0. 0 plus 2 is 2, and we get square root 2 again. Now, let's look at the domain for g of f of x. G of f of x is bracket. We need to substitute the brackets. Square root x squared plus 2. We can simplify this by going x plus 2. Now, the domain for this is all reals, but we have to respect the domain of the inner function, which is f. So x is greater than or equal to 0. We can't change that inner domain to be less restrictive. Okay, we substitute x greater than or equal to 0 here, and we get y is greater than or equal to 2. So you can reason out, or you can explicitly express the composition and figure it out. If it's not obvious, you can use your calculator and look for the min and max for the range. However, your calculator isn't always going to help you out, and sometimes you're just going to have to figure it out algebraically. Here's an example. We have f of x equal to square root 2x minus 4, g of x equals x squared minus 6. Determine the domain and range of f of g of x. F of g of x equals the square root 2x. Now we need to substitute g of x for x. So we have x squared minus 6 minus 4. So we know that the domain must be the radicand greater than or equal to 0. Radicand greater than or equal to 0. We have 2x squared minus 6 minus 4 greater than or equal to 0. We move the 4 over to the other side. 2x squared minus 6 greater than or equal to 4. Divide both sides by 2. X squared minus 6 greater than or equal to 2. Move the 6 over to the other side. X squared is greater than or equal to 8. So the absolute value of x is greater than or equal to the square root of 8. We could also write 2 root 2. So now we can write out the domain. X is less than or equal to negative 2 root 2. That's this area. Or x is greater than or equal to 2 root 2. And the range, if we substitute 2 root 2 into here, we'll get 0, because that's what we're solving for here. If we replace this with an equal sign, we will get equal to root 2. So if we have this be equal to 0, we're doing square root of 0, so y is greater than or equal to 0. Now, the reason this is hard on a calculator is because if we're looking for this domain, we cannot set a right bound to find the minimum value. So we can't figure out what x is, and we can't look for a minimum value. Same thing on this side. We can't set a left bound, therefore we can't calculate a minimum. I'll leave that as an exercise for yourself to try out. So there are two types of questions that we ask for composition. Determine an explicit equation for the composition, and determine possible equations to create that composition. And this last part is the more difficult task. So, for example, to determine the equations for the possible composite function h of x equal to square root x squared minus 3, find f and g, and usually we say such that f of g of x equals h of x. Or the other way around, h of x equals f of g of x. Okay, because there's only one variable here, it's rather easy. We take the innermost as our g, so this is the innermost function, x squared minus 3, and then we're taking the outermost function, that's remaining, and that would be square root x. Okay, it's just a square root function and an x, because we're going to substitute the inner function in for x. So h of x equals f of g of x. We can use BEDMAS, and whatever steps we use for an evaluation, they're good candidates for our inner functions. And for polynomials, completing the square gives you an inner function. And that's for, actually, specifically quadratics. And use this or risk losing marks. Remember that combining functions is not a composition. Okay, we do have a quadratic. And we need to complete the square. Complete the square, that's what CTS stands for. Okay, find f, g, h, and j such that k of x equals f of g of h of j of x. Okay, so the first step, before we even find the functions, we need to complete the square. Please look at old notes for how to complete the square if you've forgotten. So we need the first two terms, x squared minus 4x. And the thing that completes this is this, b over 2 squared, so that's plus 4. And since we added 4 on the inside, we need to subtract 4 on the outside, and we have plus 7. And we simplify this a bit. This is x minus 2 squared. This value is b over 2. And 7 minus 4 is plus 3. Now that we have a single variable, we are able to find our f, g, h, and j. And we go about this by using bed mass. Okay, you don't have to do it this way, but I'm saying this way is easier to see what's going on. So the first step we do, we're doing square root, we're doing bracket, and now we have 4 minus 2. And we have bracket squared plus 3. So our first step, our innermost function, j of x, equals x minus 2. This is our parameter, x, so we're substituting that in for x. Now, the next step of our evaluation, this evaluates to 2, and we're squaring it, and then plus 3. That means our h of x equals x squared. Next step, and we're adding 3 to our result. So g of x equals x plus 3. And finally, our last step, square root of 7. So we're taking square root of our value. So f of x equals square root x. So k of x equals f of g of h of j of x. And that is part of our answer as well. And our last example is a little bit harder. We need to find 5 functions. So m of x equals f of g of h of j of k of x. Okay, we have a quadratic. So complete the square. We have 1 over. We need to factor out an a first, x squared. This is going to be plus 2x, 6x divided by 3. And we divide b by 2 and square it. So 2 divided by 2 is 1, and 1 squared is 1. We're adding 1 times 3, so we need to subtract 3 on the outside, and we have subtract 15 as well. So now we complete the square. We have 3, x plus 1 squared. Negative 3 minus 15 is minus 18. And again, we substitute a value. Let's say 2. So we have 1 over 3 bracket 2 plus 1 bracket squared minus 18. That means our k of x, x plus 1. Our next step, we have 1 over 3. And next we're doing 3 squared. So our j of x equals x squared. And our next step, 3 times 9. That means our h of x equals 3x. And we have 1 over 27 minus 18. So our g of x is x minus 18. And finally, we have 1 over 9. So our f of x is 1 over x. And we box our answer. So m of x equals f of g of h of j of k of x. And finally, let's look at a different case. We have multiple x's, but it's not a quadratic. So we look for a pattern. We want h of x equal to f of g of x. So our g of x, this pattern is the same as this pattern. So we have minus x plus 4, and that makes our last one easy. So now we're substituting this. So this would have been x cubed plus x squared plus 7. Okay, and here, more than 1x and doesn't look like complete the square. Okay, if it's not a quadratic and it doesn't look like we can complete the square, this is how we use this strategy. And that completes this lesson.